Okay, the basic theory about the reciprocating pump is described into this section right here. This one is an air pump, the one we use to put air into our basketball or our bicycle tires. This is the normal position of the pump. Over here we got the needle. The needle inserted into the check valve in the basketball, and then inside there you got just like a piston, and then you got a check valve inside there, then you got the connecting rod, and then you got the handle, and then outside you had the cylinder. That's the normal position into it. And then when you go to the next stage of the position, we got it right here. Meaning, in this diagram, the handle is pushed going this way, from this position to this. Once it's pulled on this position, the air will flow from the back of the port right here. It goes inside the cylinder and then flows through the check valve and then inside the other side of the cylinder, in which you fill up this with air. Okay? See the position of the check valve over there. That's the key on when it runs. And then in this position, you see, you pull the knob from here to this position, and then you see the piston. The check valve here closed because the pressure that's inside on this side pushed the check valve going this way. So there's no possibility that the air will go back to the other side of the piston. So what happened? The air goes through and then exit to the outside of this pump, and then it goes to the tire or to the basketball that you want to feed with air. Okay? Now, let's go to the basic diagram of the sketches of the reciprocating pump. Okay? The one I have is this one right now. This is the first stage. This is a single suction normal position of a reciprocating pump. On this one right here, we have a tank with water, with the pressure, which is atmospheric pressure, and then we had our pipe right here. Our pipe right here. And then we had a check valve, and then from the check valve, this one is your overall pump. Okay? A check valve, then you got a pump right here, and then on the pump you have a piston, this one right here, you have the cylinder right here, and then you have a connecting rod. You got two check valves, one inlet and one outlet, and then this part right here can be connected to a reciprocating steam pump. Okay, the position of the system is this way, in which no work is being done. It's just the initial position of the system, and then we go to the next page. Right here, which the piston goes on the upward stroke, in which you're gonna have a suction over there. So let's go back over here. You got a reservoir, you got atmospheric on top of the water reservoir, and then here you got your pipe, goes to the check valve, and then goes to the cylinder and then out. Now you see here you got a dotted line here, and that means you get that's water. So the piston move up, so it made a suction. The fluid comes through here, in which you got dotted line, and goes through the check valve and fill up the reservoir, and then it passed through to the discharge check valve. But once the piston reaches the top dead center, the water stops coming in. So what will happen next? So the space right here is full with water. It will go to the next stage. That means the pumping stage. Okay? On this diagram that we have, we got the reservoir again, you got water, you got the atmosphere pressure that pushes the water. It will go through here, fill up here, and then right here. Once it goes inside the cylinder area, together with the other end of the check valve, and then the check valve to here. So what happened? This whole part will be pulled with pressure. And then the pressure from this side will push this check valve into closed position, and then this check valve will be put in open position. So when the piston goes down, the water will just get discharged. It goes like that, right here. So the process will just keep continue on. When it goes up, the piston goes up, it go in the second diagram. Once it's filled up, it will gonna come down, and then it will go to the third diagram that the water will be discharged. So the process just keep continue on all the time. If it's pumping, it's a cycle. Keep pump, discharge, pump, discharge, pump, discharge. Okay. Now, the next diagram I got over here is a two-stage pump. Okay? Meaning when it do a discharge, when the piston goes up, it will discharge fluid. When the piston goes down, it's still pumping a fluid. Okay, if we look at this piston, if you look at this diagram over here, we got the water reservoir, we got the atmospheric pressure, and then we got our piping. This diagram here, we got two sets of piping, one at the bottom and one at the top. That means the first one is at the bottom of the piston, and then the one on number 2 is on the top of the piston. So you got two suction line here, one here, and then one there, and then you have discharge piping here, and then discharge piping over there. Okay, and now we go to the first part. So this one right here, it fills up with water, but it's on the piston now is going upstroke. When it goes upstroke, that means it's discharging. This water right here on the top piston pressure will build up. It will open this check valve here, and then it will close the check valve over there. And then then it will go to the next stage of the pump, which will look like this. This one right here, you got reservoir. So when the water upstairs, the first one here, it's filled up, and then it goes here it builds up to the top part. When this thing goes up, the water here discharges over here. And the check valve here is closed, but the check valve is open. So all the water on the top will gonna be discharged. Okay? And then at the same time, the one at the bottom, okay, the one at the bottom, since it's coming up, this check valve at the bottom will open. When it's open, the water will be sucked at the bottom of the piston, underneath the piston, and then it will fill up and build up pressure. And this check valve is closed due to the pressure that's coming from the top, going down at the back of the check valve. And then, when this top part is empty, the piston now will go down, start compressing the bottom part of the pump, in which start compressing this, and then this one will open. It will be in the reverse. So this one will close, this one will open, it will discharge. Once this thing is discharged, and then the piston ready to go up, so this valve will go in this position. This thing is closed, and that one is open. discharging the fluid. So the process will just keep repeating itself because it's in a cycle. If you want to fill up a tank or even at all times with no interruption, just let it run till your project is completed to transfer a fluid from one container to another container. But the process will just be continuous, just like what I have discussed. Okay? So now, since the pump had two ends, you got the steam end in which you got your machine, the steam piston, and then the second end is the pump end. The pump end is the diagram I have discussed in here. You know, the basic how the pump works, and then the cycle of the pump, how it works inside itself. Now we'll be talking about the other end of the pump, in which we call the steam okay, this is the steam operating part here. Over here we got two sections of this. This is the whole diagram of the reciprocating pump steam operated. This section right here, from this middle section all the way to the top, that's the piston, steam piston end. And then at the bottom part, this is the pump end, reciprocating pump end. Okay? The way it works is just the steam goes up and down, and then the piston on the pump goes up and down too. As it goes up, the bottom part of the pump will do suction, and then the top part of the pump will be discharging the system. Okay, and then we got here the reciprocating pump, the steam driven reciprocating. Okay, on the parts of the steam reciprocating machine is you got the steam cylinder right here, and then you got steam piston, and then you got rings on the piston, and then you have a bottom port, and then sliding valve, steam inlet, steam chest, steam exhaust port, and then you got the top port. And over here you got the discharge and the suction for the pump, and then the piston, the liquid cylinder. Okay? I won't be discussing so much about the steam end of it, but over here is just like here on this diagram here. Well, anyway, if the centrifugal pump is run by electric or diesel engine, you will have this type of mechanism. They call it a eccentric type mechanism. You got the piston is connected to here, to the rod, and then you got an eccentric mechanism. This one rotate, and then as this thing rotate, this linkage here will let it bend, going in, and then it make it position, so that this valve, the piston will just slide back and forth. So, you know, when this one is here, you know, and then that one, the piston will go that way. And then when it's in this position, the piston will go that way. And then the way they make this, it's designed that makes sure the linkage and the piston are in the equal distance to the reference with the driver. Yari na kataw.